Okay, so we're looking at a concept called partial variation. Last time we were looking at direct variation. So if you recall, direct variation occurs when a linear graph, and note that it does have to be linear. Okay, so this doesn't work if the graph is curving, swerving, or not a straight line in a single straight line in that case. So direct variation occurs when a linear graph passes through the origin, which is the 0, 0 point on the graph. So it's kind of starting value is 0, is sometimes what we say. The equation is also written in the form y equals mx. I believe some of the example questions use k instead of m, but the idea is that there's some variable value here, some constant value there. So m is a constant value that relates x to y. So if you multiply x by this value, you'll get the y value on the graph. It is known as the rate of change, that m value. Remember, the rate of change is also known as the slope of the graph, and it is calculated using the formula rise over run. So we use our our rate triangle. We make a right triangle and we count up the rise and the run, again, always running left to right. So that's a quick little look at the direct variation. So now connecting that to partial variation occurs when the linear graph does not pass through the origin. So visually, very easy to pick out the difference between direct and partial, as partial variation does not pass through this origin point here. As long as it's not touching that origin point, and it's a linear graph, we have a partial variation situation. The equation is very similar. It still has the rate of change times x, so that portion is still the same. The difference being that we're adding a constant value or subtracting it, as the case may be, from the graph. This constant value, this b value that we're subtracting or adding, it is the point where the line crosses the y-axis. It's the y-intercept. So normally this graph would be along here, going through the origin to some degree, but we've subtracted a value from it and it moves it down, and whatever value this point is at, whatever y value, that is the b value. So in this case, it would be negative. In this case, we've added something to move it up to a positive value. It's also called a fixed value because it is constant. It's not changing. So sometimes we use the term fixed value. So we can look at graphs and pick out whether they are partial variation, direct variation, or neither by looking for the two factors. Is it a line? Then it is one of the variations. And if it goes through 0, it's direct. If it doesn't go through 0, it's partial. So we look at this first one here, this point here, going through the 0 value here, fairly well, my poor drawing. So this would be an example of the direct variation, and I've underlined there. I'm just going to use P, D, and N. So that is a direct variation. In the next case, well, it goes through the 0, so it must be direct variation other than the fact that it's not a line. It's a curved exponential type of graph here. So this is neither direct nor partial variation because it is curving. In this case here, we have a line that is not going through the origin. And thus, since it's a line and not going through the origin, this is partial variation. The next one here, again, a line not going through the origin, partial variation. And again, my last graph, very similar to my first one, it is going through the origin and it's a line, so it's direct variation. We can work with this as well using tables of values and graphs and graph it. In this case here, what we have is the cost of a data plan based on usage. So 0 megabytes of data costs $10, 50 megabytes of data will cost you $12.50, and so on. So the first thing we want to do is graph this relation. So plot some of these points here, 0 and $10. So on the 0 value on my x-axis, and then $10 on my y-axis. Again, I'm using a broken line here, so that we are skipping a couple of those values. And again, if you start like this, then you can use that in your graphs. At 50, it's 1250. So 50 and 1250 is about right here. I'm just going to put a light point there because it's not on a grid, all the grid lines. But I do have one, 50. Oh, it is right. It's right here. Sorry, I'm misreading my 100. That is 100, not 200. So 50 and 1250, 115, 150 and $15, and where am I here? I'm messing this up, aren't I? $115, $150, and $150 and $17.50, $220 and $250 and $22.50. Okay, so I got those nice points on there. I can then connect the dots, and it would continue on like that. So there's my line. I have it all laid out with it starting at 10. So because it's starting at 10, this would be a partial variation example, because again, direct variation starts at 0. So because it starts at 10, we have partial variation. What is the fixed cost? Well, again, we said the fixed cost was the starting value there, that y value, the value where it crosses the y-axis. So it crosses here at 10. So the fixed cost is $10. Because the graph crosses the y-axis, there would be our justification for that. What is the rate of change? So recall the rate of change was the change in cost as we go up, so we can make ourselves a rate triangle on this graph. I can pick 2 points. Let's pick 15 here, and we'll go up to 20. So from 15 to 20 on the horizontal or in the vertical axis, and then we'll go over here to from 100 to 200. So there's my rate triangle. Again, it's got to be a right triangle. So the change here, we're going up from 15 to 20. So the rise is up plus 5. Again, even though we're going up 2 squares, we're increasing from 15 to 20 between that space. And then from this space to this space, we're going from 100 to 200. So that's an increase of 100. And so that is our run. Again, we always read the run this way. The rise can be read up or down. If it was going down, then it would be a negative value for the rise. The run is always positive. So what's our rate of change? Well, our rate of change is equal to the rise over the run. And so it's equal to 5 over 100, which would simplify down to 1 over 20. And we can even write that as a decimal if you wish. And as a decimal, the rate of change would equal 1 divided by 20. And you would get yourself 0.05. So the rate of change is 5, meaning that for every megabyte of data, we're going up by 5 cents. And again, this becomes the rate of change becomes a unit rate, and so that is the cost per unit, 1/20th of a dollar or 5 cents. So how do we know this is partial variation? Well, the graph is linear. And it doesn't pass through the origin. So those are, again, the two key parts. It's got to be linear and doesn't pass through the origin. And now we want to create an equation for this. So we can make an equation using that general formula, which was y equals mx plus b. Again, m was our rate of change. B was the y-intercept value, the value that it crosses the y-axis at. That's our fixed cost. So this is our b value right here. And this right here is our m value. So our equation, y equals 0.05x, and then we're going to have a plus plus 10. So 0.5x plus 10. And that would allow us to figure out the monthly charge based on any value of data. So it could be 100, if we use 100 megabytes, 0.5 times 100 plus 10. If we used 1 million megabytes, 0.5 times 1 million plus 10, and that would tell us our monthly cost. All right, sometimes we're working with these not from just data, but from words. So does each of these cases represent a direct or partial variation? Well, in the first one here, Tim earns $18.95 per hour. So all we need to do is think about what happens at 0. If Tim does not work any hours, he will get paid $0. Thus, this is direct variation. In the next one, Sam gets $50 per day plus 10% commission from each sale she makes. So 10% commission means for everything she sells one item, for $100, she'll get 10. And so she gets money based on the number on the sales, 10% from each of those sales. So how much she sells each day will determine her wages. But no matter what, she's starting at $50. It's $50 plus the 10% commission. So this would be partial variation. And then our last example here, Rick has $100 in his piggy bank and he spends $5 a week. So he's starting with $100 and it's going down by 5. Thus, starting at that 100 means that that's going to be not going through the origin. So again, this one is going to be partial variation as well. Okay, and one more here. If we have Henry investing $1,000 into an account that paid $50 interest per month. So puts $1,000 in. Every month they give him $50. Write an equation to represent Henry's account value over time. Well, again, our equation is in that form y equals mx plus b. The rate of change and the fixed cost. So which of these values is fixed? He gets paid $50 per month. So that should give us an idea that this part is not the fixed cost, but the rate of change. And the key word there should be that per. That per should tell us, okay, every month he's getting that. That's a rate. So he's getting $50 per month. Thus, that $1,000 that he first put in where he started, his starting point, this is fixed. Doesn't change. What he started with is always what he started with. You can't start with a new value. So our equation would then be y equals 1,000. Sorry, wrote that wrong. It would be y equals 50 the rate of change times x plus 1,000. So he starts with $1,000 and it's 50x to increase that. You could also write this, and this is perfectly allowed. It doesn't make any difference, but you could write the equation y equals, as I was going to write it, $1,000, his starting value, plus the 50x. Doesn't matter. Both of them will result in the same answer. This one here is just, we usually state the formula as y equals mx plus b, but as long as the rate of change is with the x and the b value is the one that is the constant added by itself, it doesn't matter which order you write this in. All right, and then the last part here, how much will he have after 12 months? How about 7 years? Well, x was the number of months, right? It's $50 per month, so 50 times the number of months. So in the first one here, y equals 50 times 12 plus 1,000. And so if we do 50 times 12, we're going to get 600 plus 1,000, or y equals $1,600. So after 12 months, he's going to get $1,600. Now the next one, 7 years, we do not do 50 times 7. Why don't we do 50 times 7? Because 7 years is not the same as months. Remember, he gets $50 per month, so we need to change that 7 years to months. So it's 7 times 12, which is going to give us our number of months, or 84 months. So 50 times 84 plus 1,000. So 50 times 84 is going to give us 4,200 plus 1,000. And then y equals 5,200. So he'll have $5,200 in his account after 7 years. So again, fixed cost, when there's something fixed cost, a starting value that is not on the y, or is not at 0, then we have a partial variation situation. And again, if there is no fixed cost, it starts at 0, and in that case, then you're just working with direct variation.